Hi, well, now we're going to start chapter 6, polynomials and factorization and solving polynomials. This section 6.1 is kind of an introduction into factoring, and then we'll get more into the factoring in section 6.2 and 6.3. But right now, it's just kind of an introduction. In this first page, we're going to talk about some reasons on why we factor. And, what does a factoring look like? And then what could it be used for? So for these purposes, in these examples, the factoring will be done for you. So here, if you look here, well, let's talk about the principle of zero products. Now, this is a principle that you should already be pretty familiar with. It says that if you have two numbers that multiply to be zero, then one or both of the numbers needs to be zero. Mathematically, what does that look like? Well, if you have two numbers, let me get another sheet of paper here. I have a little bit more room. If you were to multiply, let's say, two numbers together, and you wanted it to equal zero, one of those numbers has to be zero, but not both, either one or the other. So you could have a 0 and a 3. 0 times 3 is 0. Or the second one could be a 0, and this one could be a 4 or whatever. It doesn't matter what that other number is. Any number times 0 is 0. Even if you had three numbers, and I'm going to use parentheses for these three numbers. Even if you had three numbers that you were multiplying by and you wanted them to be 0, if you were multiplying these numbers together. So here, if the first one is 0 times 5 times 10, you get 0. Or if the second number happens to be 0, it doesn't matter what these are, -10, -5. All right. You still get 0, just one of them, or the third number. So you kind of have the idea that when we have broken things, we're going to break polynomials into factors and then set each of these equal to 0, because only one of them has to be 0. So let's look at that idea here. Now, in this example, now again, this is called the zero product principle. I'll just say set it equal to 0 and solve it. Here, suppose we wish to solve the equation 3x parentheses x plus 4 equals 0. This right here is what section 6.2 and 6.3 are dealing with, is how do you make your polynomials look like this? And that's what we'll be using a couple of methods. All right, what values of x will solve this equation? You need to realize that right here you actually have three numbers, 3 times x times this. But we're just going to lump that into one. All right, one of our numbers that we were talking about. So one of these has to be 0. Either that one has to be 0 or that one has to be 0. Now these parentheses, this x plus 4 represents, if you were to put an x in, this represents one number. Every parentheses represents one number. And this number out in front with the variable represents a number. So either 3x is going to equal 0, that first number, or our second number, which is x plus 4, has to equal 0. And if one of these is true, then when you multiply them, you'll get 0. If one of them is 0, then not both, just one of them has to be 0, then the product is 0. So you solve each of these. So we're going to set each part equal to 0 and solve them. So we divide by 3. There's one of my solutions, x equals 0, because 0 divided by 3 is 0. The other part, -4, here's my other solution, x equals a -4. So we have 0 or a -4. Don't put parentheses around them. It's not an ordered pair. It's not an interval. It's just it's just the solution to this equation. X is 0 or X is a -4. So if you were to put 0 in for your X's, you'd have 3 times 0. You will get 0 because 3 times 0, this is 4. 3 times 0 times 4 is 0. Or if the X's are all a -4. So we have 3 times a -4, -4 plus 4. We get 3 times a -4 times that's 0. And I know that when I'm multiplying here, if one of them is 0, the answer is 0, which is what we wanted. So in order to use this zero product principle, you must have a 0 right there. You must, or we can't do it. All righty. So we just break it apart, set each part equal to 0 and solve it, and you're done. Let's look at this one. Here I have 2 parts. I have X minus 3 and another number, X plus 2. So one of them has to be 0. So you set them both equal to 0 and solve them, and you'll find your solutions. In this case, we'll have 2 solutions. In this case, we had 2 solutions. So we add 3. X equals 3. Subtract 2. X equals a -2. So those are our 2 solutions. Obviously, it's the hard part is getting these right here, these parentheses, which is our next couple sections. We'll do a little bit here. But for now, they've done the hard part for you. You just set each number, each of those represents a number equal to 0 and solve. Okay, now this one does occur in the homework, and it's a little bit different here. They use the function notation, and they want to know, okay, if all the X's become A's and you set it equal to 0, solve it for A. So I'm going to put these. We know that in the parentheses, that goes in for the X's. So A, 3A plus 2, and then we set it equal to 0. And solve it. It's factored for us. It's broken down into parts. So we'll set A equal to 0. And some people forget that variable out there, but it does have a purpose and it does have a solution. And then this right here. So subtract 2. And then divide by 3. So A is a -2/3. So 0 and a -2/3 are your solutions. All righty. Okay, let's look at this last example here, and we may come back to this if I remember and if we have time. But looking at this, can the same process that we used above be used to solve this equation? Can I set this equal to 0 and this equal to 0? No. And you can't set them equal to 9 either. That you can't do that. So this is a no. This has a whole other process to solve this one, which we'll look at in probably the next couple of sections. All righty. So this is a no because that's not 0. You cannot use this process at all. Actually, to tell you the truth, those of you, most of you have probably done this. You multiply this through, bring the 9 over, so then you set it equal to 0, refactor it, and then solve it. All righty? Okay. Now, we're going to start factoring. And the very first thing that we would do when we're factoring is we look for, and people forget this because, we'll use it, and then pretty soon you won't have to do this process. And then we'll start, then one will creep up. But what we're going to do here is we're going to look for common factors. All righty. And sometimes they call it the greatest common factor. In the above examples, we were already Okay, we were already given the factored version of the equation. Our goal is to be able to factor the equation ourselves. One technique that should always be done first is to look for common factors. These are factors that are common to every term of the polynomial. So we're going to look for the greatest common factor, and we're going to take it out. So here you look at your separate terms and you look at the numbers and you say, okay, what's the largest number that goes into 6 and 18? What's the largest number that goes into both of those without a remainder? Well, that would be a 6. Okay. Now you look at variables to go with the 6. This one has a y squared and this one has nothing. So there is nothing in common. All right. Otherwise, we would have picked, actually, when you're pulling these out, you pick out the smallest of the variables. Well, we'll talk about that in the next one. All right. So our answer, we have a 6. We're going to factor it out. We're going to bring it out. To find out what's in the parentheses, we're going to pull the 6 out. You ask yourself, what times 6 gives you 6y squared? What do I multiply these two to come back to my original? And that would be y squared. Okay. 6 times y is y squared. Now, what do I multiply the 6 by to get the 18, the minus 18? Well, 18 divided by 6 is 3. So you can use division to tell you what you'll be multiplying by. 18 divided by 6 is 3. So 6 times a minus 3 is 18. And you're done. All right. You're done factoring that one. So we're just pulling out what's in common and putting it in the front. You can check these. When you multiply, you always come back to the original, always. And it's important not to forget to pull this out when you start to factor. All right, let's look at this one right here. Doesn't say decreasing order. We look at the 30 and the 20. What's the largest number that would go into both of those? Well, it would be a 10. Goes into both 20 and 30. That's the largest number. Now we look to have a common variable. And this right here, you'll use the smaller one because you have to divide it in. All right. And if it was a 5, you couldn't divide it into this one. You'd have an X on the bottom. So when you have a common variable, choose the smaller one to pull out. Okay. Now let's do that. What's left? All right. What do you multiply this by to get this? 3. Okay. Plus. What do you just a 3 because you've already got the X to the 4th. Okay. Now, what do you multiply this by to get the next term? Well, we have to have a 2, but we also need another X. X to the 4th times X, adding exponents, is X to the 5th. So when you multiply them, you should come back to the original. So this is just kind of a review of pulling out the greatest common factor. Okay, we're going to skip the next one. And we're going to go to this one right here. It's kind of the same idea without as many variables. Yeah. Well, okay. Maybe we should look at this one. Looking here, we've got 8p to the 6th q squared minus 4p to the 5th q cubed, because this one might help some people understand. All right, so you look at the numbers in front, and we have an 8, a 4, and a 10. What's the largest number that goes into 8, 4, and 10? And remember, when you learned this earlier, you may have learned trees, and then you just take out the smallest of what's in common. Or, some of you know that you can divide all of these. The largest number would be a 2. All right, 2 goes into 8, 2 goes into here, and 2 goes into here. And then they all have a p, and the smallest is p to the 4th. They all have a q, and the smallest is q squared. And that's your greatest common factor. So now we start asking ourselves to get the first term. What do I multiply this by, these two, to get this one? Or you can also look at division. If you take this divided by this, it'll tell you what you multiply by. But 2 times 4 is 8. I have p to the 4th, but I need p to the 6th. So I need 2 more. Q squared, that's it. This times this gives you here, this right here. Now the next, what do I multiply these two by to get this one? Well, it'll be a minus 2 times 2 is a minus 4. I need another p to the 1st, p to the 4th. I need a p to the 5th, and another q. I've got a q squared. I need a q cubed. So if you multiply these, you come back to this. Plus, what do I multiply this by to get the 10? Well, 2 times 5 is 10. P to the 4th, p to the 4th. I don't need to put anything there. I've already got the whole p to the 4th. Q squared to a q to the 4th, I need 2 more. And there's your answer. Okay, taking out the greatest common factor. Let's do another one. Okay, now we have 4 terms. Same thing. Pull out the greatest common factor. Looking at 15, 12, 27, and 3, the greatest common factor is going to be 3. All of these are divisible by 3, and it has to be all of them. Otherwise, you don't use the coefficients in front. You won't pull out a number. But we can pull out a 3. They have x to the 5th, x to the 4th, x to the 3rd, x to the 2nd. So they all have an x, and the smallest of all 4 of those is x squared. So that's what we're going to pull out. All righty. So let's use our division idea. This divided by this gives me a 5. 5 minus 2 is 3. Check it. If I multiply these together, I get 15 x to the 5th. So now this negative 12 divided by 3 is a negative 4. 3 times a negative 4 is a negative 12. X to the 4th divided by this, you subtract exponents and you get x squared. Perfect. Plus 27 divided by 3 is 9. 3 times 9 is 27. X cubed over x squared gives us, we need another x. All right. Now, this is important because some people stop here. But here, minus 3 divided by 3 is a minus 1. X squared, we don't need anything. You have to have that 1 there. You have to have that 1. Because when I multiply these, I have to come back to the original. All right, so in here, you're just asking yourself, what do I have to multiply this outside to come back to the original? All righty, perfect. Okay, let's keep going. If the leading term has a negative in front, the highest power has a negative in front, we usually will factor out that negative as well. So in other words, in looking at here, I've got a 4 and a 24. What's the largest number that goes into both of those? Well, that would be 4, but because this is leading is negative, I'm going to pull out a negative 4. Okay. It just makes the rest of the problem solving easier. This divided by this is going to be a positive x. Check it. This times this is this. Minus 24 divided by a minus 4 is a positive 6. Negative over a negative is a positive. Check it. Negative 4 times a positive 6 is a negative 24. You're done. All right, let's look at the other one with this idea of the leading coefficient being negative. What goes into 2, 6, and 2? Well, it would be a 2. That's the largest number that you can divide all of those by. Because this is negative, this leading coefficient, I'm going to pull out a negative 2. Oh, we'll have room for my x. So we're going to pull out a negative 2, and they all have an x, and the smallest is x to the first. So if it's negative, the leading term is negative, pull out the negative. Now, this divided by this is a 1x squared. X to the first times x squared is x cubed. And then if you're using the division, you subtract exponents and get the 2. Now, what do you multiply this by to get this? Or 6 divided by a negative 2 is a minus 3. 2 minus 1 is just an x. Let's check it. Negative 2x times a negative 3x is a positive 6x squared. It works. Okay, last one. This divided by this, negative 2 divided by a negative 2 is a positive 1, and then the x's cancel. Check it. This times this gives you that. Okay, and we're done with that. All right, so I'm hoping that pulling out the greatest common factor, you kind of are understanding that. Okay, the next thing is kind of a story problem. Suppose that a baseball is thrown upward with an initial velocity of 64 feet per second and an initial height of 0 feet. Its height at any time can then be given by the equation. So all they've done is told you about this guy, and we're just going to be using it. So if you don't understand all of this, that's okay. They give you the equation to use and just concentrate on that. Find an equivalent expression for h of t by factoring out the common factor with a negative coefficient. So they want you to factor this. They want you to factor that equation. Well, what's the largest number that goes into 16 and 64? Actually, it's 16. Okay, 16 does go into 64. So this will be a minus 16. Okay, we're going to pull out a negative. Leading coefficient is negative. And we have t squared and t to the first. We'll pull out just a t. Always use the smaller of what's in common. All righty. This divided by this, okay, this divided by this gives you a positive 1t. 2 minus 1 is just a 1t. But check it just in case. Negative 16t times t gives you a negative 16t squared, adding exponents. All right, 64 divided by a negative 16 is a negative 4. Okay. Negative times a negative is a positive. T over t, when you divide these, they cancel out. So that's the answer they wanted. Okay. Is this right here? And I believe you have one of those on your homework. Okay, now we're going to look at factor by grouping. All right, so we normally do factor by grouping if I give you a polynomial with 4 terms, but they have it kind of set up. They've done the little bit of the hard part for you. So what you do is we actually have 2 groups, one here and one here. And you're going to pull out what's in common. So this is related to the greatest common factor. So what's in common with this group and this group? Well, they both have an a minus b. So I'm going to take out an a minus b from that group, from each of these groups. What's left in this one is going to be an x plus 5. Plus, in this group, what is left over? And that's going to be an x minus y squared. Let's check both of these. Again, this group, I pulled this out and that's what's left. This group, I had pulled that out and put it in front and that's what's left. If I multiply these, I get this. If I multiply those, I come back to this. Now, Pearson may want you to clean this up in here. You've got a parenthesis separated by a plus sign. So you've got x plus 5 plus x minus y squared. So a minus b, you can have 2x plus 5 minus y squared. I don't think the order is going to matter. But that's factor by grouping. That's in the process. Chances are we're not going to have anything that looks quite this difficult. So we're going to go through a sample that's a little bit easier. So to use factor by grouping, we have 4 terms. Okay, and they may even tell you use factor by grouping. Now, look for something in common with all 4. Well, this has a 1, a 3, a 4, and a 12. Well, you can't pull out a 3 because you can't pull out a 3 from those. You can't pull out a 4 because you can't pull out a 4 out of these 2. So it doesn't look like there's anything with these 4 coefficients that I could pull out. They all don't have an x, the 12. So there's not a greatest common factor to pull out in front like we were doing in our previous examples. So here, we're going to start the grouping then. All right. What we're going to do, there's 2 types of grouping. We're just going to do the one where we group the first 2 and those, and the last 2. And you deal with them separately. Now, this group, what's in common? What could come out of this group? Well, there's a 1 and a 3, so there's not a number that I could pull out. But they both have an x, and the smallest is an x squared. And we're just concentrating on this group. So we're ignoring, I gotta turn that over. We're ignoring that group. So here, x times x squared is x cubed plus x squared times 3x squared. If you were going back to this one, you divide those, you get x. And then here in division, the x squareds cancel. Or you can think of it that 3 times x squared gives you that. Okay. So you pull out what's in common on the first 2. That's it. Then you go to the next 2. We have a plus. And you pull out what's in common here. What could I take out of a 4x and a 12? Well, 4 goes into both of them. Can't use an x because that doesn't have one. So we have a 4. Okay, what times 4 gives you 4x, or 4x divided by this, the 4's cancel, x. Multiply it, yep, you bet, you come back. 12 divided by 4 is 3, plus 3. Multiply it, you come back. Okay, so now can you see that within these groups here, within this group and this group, I have an x plus 3. So I'm going to pull that out in front, just like I pulled out the x squared there. So I'll have x plus 3. I'm going to put it out of this group. If I pull it out of this group, I have x squared. If I pull it out of this group, I have a plus 4. And there you're done factoring. So you just group the first 2 and the last 2 and pull out what's in common, and then pull out what's in common and put it in front with parentheses. Let's try another one. Okay, this one right here, we may have to do some rearranging. Yeah, we do. So in order to pull out what's in common, because if I group the first 2, there's nothing in common. And well, we should always look for what's in common with all of them. And there's not anything. You can't pull a 3 out of the 4. This one doesn't have a t. All right. So we did that. We need to do that first. Now you ask yourself, if I group those first 2, what's in common with a 15 and a 4? There isn't. If I group these two, what's in common between a 20 and a 3? Well, there's not. So I'm going to rearrange this so that in a way that I think I can pull stuff out. So I put the 4 and the 20 together and the 3 and the 15 together. Okay. And I did it in descending power too, which I guess that helps. All righty. So now it's also in descending power. Okay. Let's go ahead and group the first two and factor out what's in common. Between a 4 and a 20, we have a 4. Okay, great. I'm hoping that I'm sharing my screen. My internet almost went out, and I'm like, oh, do that. Let me see, make sure that visualizer, share. Okay, so I'm hoping that we're back. Wow. All right, so here, what we did is we just pulled out a 4t squared. And if you multiply, you come back to the original. Now, this next one, this is the tricky part. When I put parentheses here, I've created a -1 times what's inside. So when you put parentheses and there's a minus there, you have to change this sign. Okay. If you want to remove the parentheses, then you would multiply it through and you would come back to the original. So if you have the negative outside the parentheses, make sure you change that sign in there. Okay. Otherwise, they're not equivalent statements. They're not equivalent statements. All right. So now what I'm going to do here is I'm going to pull out a 3. And this divided by 3 is t. 15 divided by 3 is a +5. All right. So I have to write the original. I kind of messed up with the original up here. So we can check that last part with our signs and make sure everything's going to work out. Okay, that was the original before I put the parentheses in and changed it. So if I multiply this, I get a -3t. And if I multiply this, I get a -15. Okay. So here, when you put that parentheses in and you take out a 3, okay, you change that sign. The sign will change. Okay. In the middle. Now, what's in common with these groups? It's a t + 5. If I pull it out of this group, I've got 4t squared. If I pull it out of this group, it's a -3. And you're done with that factoring, with that grouping. So just, just watch when you put that negative outside, that you watch that sign there and make it positive. Okay. And you'll also know because these need to match in sign as well. All right, let's see what they have for us next. Another factor by grouping. Okay, let's try it. AX plus BX, AY minus Y. AY. All right, we're going to group the first two together. Plus, it's a plus, so I don't have to change the sign. Okay. So let's factor out an X. That's what's in common. And that leaves us with an A. X times A is AX. If you divide these, the X's cancel. Minus, let's see, we take BX divided by X, the X's cancel. We get this. Okay. Plus. We're going to pull out a Y because that's what's in common here. and we're going to have a b, by divided by y is b, minus ay divided by y is a. All right, we have a problem. I have an a minus b and a b minus a. They're opposites. So if I want them to match, I'm going to have to multiply one of these by a -1. And we're going to do this one right here. So if I bring out a -1, I can switch those. Because if I multiply it, I go back to the original. Negative times a positive is a negative times a negative is a positive. All right. So if you want to switch them, you have to bring out a negative, and we'll be using that in chapter 7. Okay, now we'll take out an a minus b between this group and this group. This leaves us with an x here and a minus y there. If you multiply this times x, you get this. This times a minus y, you get that. All righty. So the y times that is that. All righty. So that's factor by grouping. Just group the first two, take out what's in common, be careful of subtractions, and then just pull out what's in common with your two new groups. Okay, what we're now going to do is we're going to solve. We're going to use the factoring. Now we can use the zero product property with non-factored equations by first factoring everything. You need to make sure that you first get everything on one side of the equation and have it set equal to 0. So begin by moving all terms to one side of the equation. Does it matter? Well, it does in a way, because you can make it harder on yourself by moving it to the wrong side. We usually keep the leading term positive. So we move things so that that highest power is positive. Then your equation should now be set equal to 0. Then we'll factor, using whatever method we need to. And then we will solve each of our factored groups. So let's go through an example. First off, this is already positive, so we're going to leave it, and we're going to move this over. So we'll have 6x squared minus 30x equals 0. All right, here's our first step. Set it equal to 0 in order to solve. Now we're going to factor. And the only one we know how to factor is the greatest common factor. So what would go into 6 and 30? Well, 6. X squared, x to the first. We take the smaller of what's in common. They both have x's, so we're going to use x to the first. Okay. You can use division to figure out this term. 6 over 6 is 1, and then you end up with a squared minus 1. You end up with x to the first. Multiply it to double check. It works. 6x times x is 6x squared. Negative 30 divided by 6 is a minus 5, and then the x's cancel. Check it. This times this gets back to the original. So we're just kind of rearranging them. Okay, now I know that when I'm multiplying numbers together, one of them has to be 0 in order to be equal to 0. Either this times this, either this number is 0 times something, or this one's going to be 0. So you go 6x equals 0, or x minus 5 equals 0. One of those groups has to be 0. Divide by 6, x equals 0, add 5, x equals 5. So your solution is 0, 5. Put those in. If you put in 0, the left will equal the right. If you put in 5 and square it, and get 25 times 6, 150. 30 times 5 is 150. So the left will equal the right. All right, let's do this again. The highest term is positive, so we're going to move the 7x squared over. This is called setting equal to 0. Okay. Now we pull out what's in common, our greatest common factor. So we pull out a 7. Okay, they have a 7 in common. And we're going to pull out, oops, sorry, I put my parentheses too soon, because they also have an x in common. So we're going to pull out an x, and the smallest is x squared. Okay. Now, this 21 divided by 7 is 3. X cubed divided by this is x to the first. If you multiply, you go back. Minus 7 divided by 7 is a minus 1. You could put the 1 in there, but I'm not. Well, I guess we may have to. X squared over x squared is also 1, so you do need that 1 there. Multiply it out. This times this gives you back to the original. Now, let's set these equal to 0. What does this mean right here, this x squared? You know, we had the 6x. That was pretty obvious. But what about this? This just means 7 times x times x. Okay, without using radicals to solve it, we'll just do it this way. So so this x can be 0 or this x can be 0. But either way, you only list those 0 once. All right. So you've got a 0 and a 0, but you only list it once. Okay. These out in front, you'll always have an x equals 0. Here, one moment, please. I need to take this. Okay, so I had to pause it there for a second. So when you have these x squared, these two of them, you'll still just have a 0. All righty. Then you set this one equal to 0, and you add 1, divide by 3, and x equals 1/3 or x equals 0. Those are your solutions. So you set it equal to 0. You pull out the greatest common factor. That's a number that goes into the largest number that goes into 21 and 7, which is 7. I'm going to try to keep these numbers kind of low so that it's not too hard to see what's the largest number that you can pull out. And then you pull them out. Here, always check. Make sure when you multiply, you come back to your original. And then you set each group equal to 0. And if you've got that double x, then you just use 1x equals 0. Okay, if you have a single x, it's just x equals 0. All righty, perfect. Let's see what we've got on our last page. All right, graphical solutions. What are we doing when we're solving these, when we look at a graph? Exactly what points are we finding when we find these solutions, when we set it equal to 0 and solve them? So it is important to be able to understand what we are doing graphically. This can especially be helpful when in more advanced math courses where you can use a graphing calculator. So they want you to solve the equation x squared equals 6x algebraically. To do that, we would set it equal to 0 first. All right, so that gives us x squared minus 6x equals 0. And I set it equal to 0. Move the 6x over. Now, what's in common? It looks like an x to the first. There aren't any coefficients that are in common. Okay, this divided by this is x to the first. You subtract exponents. This times this is x squared. This divided by this, the x's cancel, and it's just minus 6. X times a minus 6 is a minus 6x squared, or it's just a minus 6x. Okay, so I have these two groups. This equals 0 or this equals 0. add 6. So we get 0 and 6 as our solution. Well, let's graph it. Whenever you have an x squared, it forms what we call a parabola. And this is a picture of the screen on a graphing calculator. Now, how can we use the graph to find the solutions? Well, when you set this equal to 0, you have this right here. Graphing calculator, you'll have this y here instead of f of x. But y equals x squared minus 6x, you graph this. We want to know when the y is 0. That's setting it equal to 0. So the y is equal to 0 here and here. At 0 and at 6. So when you're solving these, sometimes they call it the 0 of the function or a 0 of the graph. You're setting it equal to 0. Sometimes they call it the root. What are the roots or the root? Depending on, sometimes there's only one. Sometimes there's plural. And it's also the x-intercept or intercepts. All of those mean the same thing. Or solve. Okay. So you're solving it, you're finding the zeros, you're finding the roots, you're finding the x-intercepts. All of those are the same. And you can use algebra, or sometimes, given the graph here, I think there's one on your homework, you just look to see where are the x-intercepts, 0 and 6. Okay, so what we got graphically. So let's look at this one. Okay, without factoring this, what is this solution? What are the zeros? What are the roots? If you were to, if you were to graph it, what are the x-intercepts? Well, we go to our graph. It looks like we have one here, here, and here. I should have had a different color, but I don't. So we have, let's see, each of these tick marks is a -1. It's important to know that. -2, 2, and 3. So if you were to factor that, you would have these 3 for solutions. So if you put in a -2 in for x, you're going to get a 0. If you put in a 2 in for x, you're going to get a 0. If you put in 3 in for x, you're going to get a 0. Those are the zeros of the function. Let's look at another one. Here, find the roots of the equation or the zeros of this equation right here, and it's been graphed for you. Well, the roots, the zeros, the x-intercepts, the solution is where it crosses the x-axis, here and here. So a -2 and 1 and 3. If you put in a -2, you'll get 0. If you put in a 3, you'll get 0. So sometimes having the graph can shorten things up. All righty, and then we'll look at some more graphing in our next section. I looking back and thinking back, I went through those, the greatest common factor pretty quickly. So those of you that may be struggling with that, I encourage you to let me know, and I can go through it more slowly as far as what is that term that we're pulling out? What is that greatest common factor? Otherwise, good luck, and let me know if you have any other questions. Thank you.